All right, it's time to get ready for our Unit 3 test. And so as we go through this, make sure to let me know if you have any questions. But number one says Josh is going to Walmart before school to purchase snacks for his class. He must purchase at least 28 items. So it means it has to be 28 or more items. He has only collected $34, so the total cost must be no more than $34. So 34 is the maximum, so 34 or less. If X represents the chips, it costs 75 cents. Y represents the crackers, which is $1.25. What system of inequalities could be used to represent the region for the number of chips and crackers Josh could purchase? Write the system of inequalities. Do not solve or graph. So we're just writing the system, that's it. So my first one is going to be my chips plus my crackers. Has to be at least 28, so more than, greater than, or equal to 28. And then my cost, and so 75 cents for the chips plus the 125 for the crackers has to be less than or equal to 34, and that's it. Number two, 500 tickets were sold for a certain music concert. The tickets of the adults cost $7.50, children $4, senior citizens $3.50. So those are our three variables. And so there's gonna be my adults, my children, and my senior citizens. So I've got 500 tickets sold. So the number of adults plus the number of children plus the number of senior citizen is equal to 500. So 500. Then I'm going to throw in the money, and we got $3,025. And so 7.5A plus 4C plus 3.5S is equal to that 3,025. And so 7.5, 4, 3.5, 3,025. And then lastly, twice as many adult tickets were sold as children. So more adults, and so for every one child, there are two adults showing up. And so my adults and my children, so for every one child, we're gonna multiply by 2 to get how many adults there were. And so we gotta move one of these over to get it matrix ready. It doesn't matter which one. I'll just move over the C. So A minus 2C is equal to 0. And so my A value is 1, my C is -2, whoops, right there. My S is 0, and my answer is 0. And so now it's ready to put in the calculator. I'm gonna go into my matrix and edit it. And we'll put in all these numbers. We've got 1, 500, 7.5, 4, 3.5, 3,025, 1, -2, 0, 0. Kind of double check real quick. And then we'll do the RREF of matrix A to get there's my answer. So that's my number of adults, children, and senior citizens. And so 300, 150, and 50. That's my adults, my children, and my senior citizens. Number 3, it's already set up. We just got to solve it. Let's just make sure everything's lined up. My X's, my Y's, my Z's, my answers. This is matrix ready. And so I'm ready to just put it in the calculator. So second matrix, we'll put it in. 1, -1, 1, -8, 2, 3, -3, 4, 1, 2, 7, and 13. There's my X, my Y, and my Z. -4, 5, 1. All right, this is not matrix ready. My letters aren't in order, and so I need to make sure I have my X, my Y, my Z, and my answers. And so on this first one, I've got my X is 2, my Z is 1, my Y is on the wrong side. I've got to move it over. Anytime you cross the equals bar, it's going to change signs. So it becomes a -1, and then we have a -2. This X is 1, my Y is 3, my Z is -1, my answer is 10, my X is 1. There aren't any Y's, my Z is 2, and the -8 moves over to become +8. And then we'll put in the calculator. So 2, -1, 1, -2, 1, 3, excuse me, -1, 10, 1, 0, 2, and 8. So just make sure I got everything in there correctly. And there's my answer. And so it is some decimals on this one. If you want to, if you press math, enter, it'll turn it into fractions. I'm good with either one. You can do decimals or fractions. And so my answers are -2/3, 5, and 13/3. All right, going on. We've got Shaggy, Fred, and Scooby went out to eat. Shaggy ordered 3 burgers, 2 orders of fries, and a drink. Fred ordered a burger and a drink. So we see our variables are burgers, fries, and drinks. And we're gonna have an equation for each of them. So we're gonna have an equation for Shaggy, an equation for Fred, and an equation for Scooby. And so for Shaggy, we had 3 burgers, 2 fries, 1 drink for $6.45. For Fred, we had 1 burger and 1 drink for $2.65. And for Scooby, we had 7 burgers, 5 fries, no drink for $11.80. So I'll go back into our matrix. 3, 2, 1, 6.45, 1, 0, 1, 265, 7, 5, 0, 1180. Oops. And we'll do the RREF of matrix A. And so there's the cost of each of them. And so how much does a drink cost is what I'm wanting. And so we had 115.75 and 1.5. This was our burger, our fry, our drink. And so there's our answer right here. So drink costs $1.50. All right, number 6, a convenience store sells 23 sodas one summer afternoon in 12, 16, and 20 ounce cups, small, medium, large. The total volume of soda was $3.76. If the prices for small, medium, large are those prices, and the total sales were $28.45, how many of each size did the store sell? So we've got small, medium, and large. And so first off, there's 23 sodas. So the small, the medium, plus the large will equal 23. That's my first equation. Next off, they made $28.45, and so that's gonna be the money included. So $1 for the small, $1.25 for the medium, $1.40 for the large is gonna equal the $28.45. And then lastly, the total volume of soda sold was 376. So that's going to include the volumes of each drink. And so the 12 ounces for the small, 16 ounces for the medium, 20 ounces for the large is going to equal the 376 total ounces. And so now it's matrix ready. One, 23, 25, 140, and 28.45, 12, 16, 20, and 376. So how many did each of them? So 6, 9, and 8. That was the small, the medium, and the large. All right. Next one, Victor found $4.45 in his backpack, 82 coins of pennies, dimes, and quarters. So those are 3 variables. The number of dimes he found was, so that was is our equals. So dimes is equal to 2 more than 5 times the number of quarters. So 5Q plus 2. And so 2 more is plus 2 to the 5Q. So to get this matrix ready, I'm going to move the 5Q over. So it's going to be a positive 1 for the D, a negative 5 for the Q, and then my answer is 2, no pennies involved. There were 82 coins, so the number of pennies, number of dimes, number of quarters equals 82. And then there was $4.45. We'll put in the value, 0.01, 0.10, and 0.25 equals the 445. So there's my 3 equations. And so I'll put it in the calculator. 0, 1, negative 5, 2, 1, 1, 1, 82, 0.01, 0.1, 0.25, 4.45. And so we've got 50 pennies, 27 dimes, and 5 quarters. And I want to know all 3, so that answers my question. All right, so now we're going to graph the system of inequalities. And so for my first one, the easiest one to graph is going to be this y is less than or equal to 4. And so 1, 2, 3, 4, it's going to be a solid line because it has the equals on it. And then for the next 2, I need to get the y by itself so that I can graph it. So for the top one, I'm going to move the x over. So negative 2y is less than or equal to negative x minus 4. So just so you see what I did, I just subtracted x on both sides. And then we're going to divide by negative 2 to each piece. And when we divide by -2, it's going to flip my inequality because we're dividing by a negative. So it's be y is greater than or equal to 1/2 x plus 2. So we're going to start at 2. Oh, sorry, and this one was less than, so we're going to do kind of a light shading down below. So then 1/2 x plus 2, we're going to start here, and my slope is 1/2. So we're going to go up 1 over 2, up 1, right 2, up 1, right 2. And then we'll draw that line again. It's solid because it has the equals bar. And this one is greater than, so we're going to be shading above. And so, let's see, I'll do a different direction. So right now our common shading is this area right here. And now I've got to do the one last equation. And so x plus 2y is greater than or equal to 4. I'll subtract the x over. And so 2y is greater than or equal to -x plus 4. And then we'll divide each piece by 2. We're dividing by a positive, so I'm not going to flip my inequality. -1/2 x plus 2. So again, we're going to start at 2, but this time our slope is -1/2. So down 1, right 2, down 1, right 2, down 1, right 2. This one again is a solid line because it has the equals bar. And it is greater than, so we're going to be shading above, which means the common shaded region is going to be this region right here inside this triangle. Number 9, we'll do the same thing. I need to get the y by itself on all of them, so 2x plus y is greater than -6. We'll just subtract 2x over, and so y is greater than -2x minus 6. So we'll start at -6, 1, 2, 3, 4, 5, 6, and we'll go down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1. This one is a dotted line because it doesn't have the equals bar with it. And it's greater, so we're shading above the line. X minus y is greater than or equal to 4. We'll subtract x. So -y is greater than or equal to -x plus 4. And then we'll divide by -1, which will change all my signs, and it's going to flip the inequality. So we'll start at -4, 2, 3, 4. And it's got a +1 slope, so we're going to go up 1, right 1, up 1, right 1, up 1, right 1. It is a solid line because it has the equals. And we're shading below because it's less than. So as of now, our common shaded region is everything down here. And now our last one, 5x plus y is less than 10. We're going to subtract 5x over. So y is less than -5x plus 10. So we're going to start at 10, which is going to be at the top. We're going to go down 5. 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. And this one's a dotted line because there's no equals bar. And for this one, we're shading less than, so we're shading below. So our common shaded region is going to be this area right here, where we're above that line, we're below this line, and below this line. All right, so then our last one, it's going to probably take the longest, but I'm going to do both elimination and substitution. You can do either. I'll do elimination right here, and then I'll do substitution on the back. So first off, for elimination, I'm going to transfer these numbers into my matrix. And so I've got 1, 1, 1, -3, 2, -3, 6, -21, -3, 5, 0, -14. And so my first goal is I want both of these two numbers to be 0. And so for me, I like to compare them to row 1 and see how can I make it equal 0. So my rule for row 2 is I need it to be the same. And so I'm going to do 2 times row 1, and then we'll subtract row 2. And so my top row is going to stay the same, 1, 1, 1, -3. We're not changing the top row. But for my middle row, we're gonna do 2 times row 1 and then subtract row 2. If you need a calculator, you can put it in the calculator, but we're gonna do 2 times 1, which is 2, minus 2, which is 0. 2 times 1, which is 2, minus -3, which becomes plus. 2 plus 3 is 5. And then 2 times 1 is 2, minus 6 is -4. 2 times -3 is -6. And then minus -21, which becomes plus 21, that's become 15. And then for row 3, I need it to match, and so I'm going to make it 3 times row 1, but it'll be positive and negative, so I'm just going to add row 3. That'll cancel these out to be 0. So 3 times 1 is 3, plus -3 is 0. 3 times 1 is 3, plus 5 is 8. 3 times 1 is 3, plus 0 is 3. And then 3 times -3 is -9. Plus -14 is -23. Excuse me. All right. My next goal is I want this number right here to become a 1. And so the easiest way to do that is for row 2. I'm just going to divide it by whatever this number is. And so to make 5 become a 1, I divide by 5, which is the same thing as like 1/5 of row 2. And so we're going to divide by 5. So top row stays the same, 1, 1, 1, -3. Bottom row will stay the same, 0, 8, 3, -23. But then for my middle row, we're going to divide everything by 5. So that becomes a 0, a 1, -4/5, which if you wanted to, you can put the decimal. That's a good decimal. And then 15 divided by 5 is 3. My next goal is I want this to become a 0. And so I don't want this to change, so I'm not going to combine it with this one because that would change my 0. I'm going to combine it with row 2. And so for row 3, we're going to do 8 times row 2 to make it match the 8, and then we'll subtract row 3. Top row stays the same, 1, 1, 1, -3. Middle row stays the same, 0, 1, -4/5, and 3. But then the bottom row, we're going to do 8 times 1, which is 8, minus 8, which is 0. This one may be a little bit trickier, which if you need to, you can put it in the calculator. But 8 times -4/5, and then minus 3 is -47/5, which if you wanted to, you can put that as a decimal. Either way you want to do it. I'll just go do the decimal, -9.4. And then we'll do the same thing with the bottom one. And so we're going to do 8 times 3, and then minus -23, which is 47. All right, then like we talked about earlier, I want this one to become a 1. So to make that become a 1, we just divide it by itself. So for row 3, we're going to do row 3 divided by -9.4. So the top row stays the same, 1, 1, 1, -3. Middle row stays the same, 0, 1, -4/5, and 3. And then the bottom row, we're going to take row 3 and divide by -9.4. So 0, 0, that's going to become a 1. And then 47 divided by -9.4 gets me -5. All right, so then my next thing is I want all of these to become zeros. And so we can piece it one at a time, or we're gonna do multiple things at one time. For row 1, I'm gonna go, I'll just go do row 2. I'll do one thing at a time. Row 2, I want this to become a 0, and so I need this to become 4/5. And so I'm gonna do row 2. They're already opposite signs. And so I'm going to do 4/5 times row 3, because 4/5 times 1 will be 4/5, which will make it match. And so we have 1, 1, 1, -3, 0, 0, 1, -5. And then for my middle row, 0 and 1, those aren't going to change. But then -4/5 plus +4/5 will be 0. And if we need to, we can plug this last one in the calculator. We're going to have row 3, which is 3, and then plus 4/5 times -5, -1. All right, so we got 0 there. And so now our last thing is to get these two to be zeros. We're gonna have to piece it apart in 2 steps. Our first one, we'll do this one. And so I don't want this number to change. And so I'm gonna combine with row 2. So row 1, the rule is gonna be row 1 minus row 2. And so 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 0 is 1, negative 3 minus negative 1 is negative 2. And then everything else stays the same. And last step for row 1, to make this equal 0, we'll subtract it with row 3 so that we don't change the other 2 pieces. And so row 1 minus row 3. And so it becomes 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 is 0, negative 2 minus negative 5 is 3, and then everything else stays the same. 0, 0, 1, 0, 0, 1, negative 1, negative 5. And so these are our answers right here, which is 3, negative 1, negative 5. All right, so now let's go to the back and do substitution. All right, so for substitution, we've got x plus y plus z is equal to negative 3. We have 2x minus 3y plus 6z is equal to negative 21. And then negative 3x plus 5y is equal to negative 14. And so there's multiple first things you could do. I'm gonna go ahead and start with the bottom equation. And so I'm gonna mark it to know which equations I used. And I think it's gonna be easier to divide by 5 rather than dividing by 3, because 3 makes some repeating decimals, where when you divide by 5, it's a terminating decimal. So I'm gonna go ahead and move the 3x over by addition. And so let me go ahead and write out my steps. So we'll add 3x over. So 5y is equal to 3x minus 14. And then we'll divide each piece by 5. Where if you want to, you can leave it as a fraction, or you can do a decimal. Either way works. I'll go ahead and do decimals. 0.6x minus, that's going to be 2.8. So this box right here represents my y. Now I'm going to do the top equation for my second one, and I'm going to plug this in for the y. So I don't want any more y's. And so we're going to have x plus 0.6x minus 2.8. That's my y right there. Plus z equals negative 3. And so this becomes 1.6x minus 2.8 plus z is equal to negative 3. Between these two, it's going to be easier to solve for the z. So I'm going to subtract 1.6x and add 2.8 to both sides. So those are gone. And z is equal to negative 1.6x. And then negative 3 plus 2.8 is going to be a negative 0.2. So this box right here is my z. So now I've got to use the middle equation last. And so I'm going to plug in my y and my z into the middle equation. So we're going to have 2x and then minus 3. In place of the y, we're going to put 0.6x minus 2.8. So that's my y right there. And then plus 6 times, and then my z is negative 1.6 x minus 0.2, probably shouldn't have written it right here, equals negative 21. All right, and so this is my z right here. And so now to start off, we're going to do distribution. And so 2x is going to stay. And so I have negative 3 times 0.6 to get negative 1.8x. And then negative 3 times 2.8, negative 2.8 gets me positive 8.4. And then that's gonna be 6 times negative 1.6. 6 times negative 1.6 gets me negative 9.6. And then we have again a positive times a negative. And so 6 times negative 0.2 will give me negative 1.2 equals negative 21. So now I'll combine like terms. So 2x, negative 1.8x. I forgot my x right here. And negative 9.6x. And so we're going to have 2 minus 1.8 minus 9.6 will get me negative 9.4x. and then we'll combine 8.4 and negative 1.2, which will be 7.2 is equal to negative 21. We'll subtract the 7.2 over. So negative 9.4x is equal to negative 28.2, and then we'll divide by negative 9.4. Oops, I'm going off the screen. And so x is equal to negative 28.2 divided by negative 9.4 gets me 3. So my x value is 3, and now to find my y and my z, we'll plug in this 3 into my other equations. So for this one, negative 1.6 times 3 minus 0.2. So negative 1.6 times 3 minus 0.2. Just put in my calculator, negative 5. So that's my z. And now I'll come up here to the y, so 0.6 times 3 minus 2.8. So 0.6 times 3 minus 2.8 gets me negative 1. And so there's my answer. Whether you do elimination or substitution, you should get the same answer. So once again, if you have any questions, let me know, and hopefully you're ready for the test.